Hi y'all, welcome to Mrs.D Math. Today we're going to be going over ordering and comparing rational numbers. We did go over a video discussing what a rational number is, so if you don't remember, you can go back over that video. So let's go ahead and get started. The first step whenever we're ordering and comparing rational numbers is to use a number line to order positive and negative rational numbers. This includes fractions and decimals. A rational number, just to review, is going to be any number that can be represented by a over b as your form, and b cannot equal 0. So it can be a fraction. Fractions can also be converted to decimals. It can be positive or it can be negative. So let's go ahead and use that number line here. So our number line here is showing us that 0 here is in the middle. 0 doesn't always have to be in the center, but 0 is the center of positive and negative numbers. There's arrows on both ends of our number line, just showing that it's going to go on forever. It doesn't ever end. So on the right side, I have my positive values. On the lower part, we have fractions, and on the upper part, we have decimals. Now this is not marking every single position, but this is showing that from 0 to your whole number 1, we have all these fractions and decimals in between, and there's actually more of them. I just marked 10 spaces, so you can see that the right of 0 we have 1/10, 2/10, 3/10, 4/10, 5/10, and so on. So 10/10 would be 1, because 10 over 10 is equal to 1. So if I were to get down over here and have 10 over 10, then that would equal 1. Now these fractions are reduced because this position is 8/10, which is 8 over 10. We've reduced it to 4/5. So 4/5 and 8/10 are equivalent. If you look on the left side of our number line, over here we have the negatives represented between 0 and 1. I'm sorry, between 0 and -1. So all it is taking the same as the right side, the positives, and it's working backwards for the negatives. That means that a negative 8/10, the equivalent fraction is going to be negative 4/5. So we reduced it, but we did keep our negative sign. So the first step is to use the number line to order our rational numbers. For our second step, we want to convert fractions to equivalent decimals, or we can convert decimals to equivalent fractions so that we can put them in order. So let's go ahead and try this out, and we're going to convert some fractions and decimals. So we have the fraction 1/4. In order to turn 1/4 into a decimal, I need to have the top number in the box, and I'm going to divide by the denominator or the lower number. Now 4 does not go into 1, so I'm going to add a 0 here, but I have to keep going, and I can't change the value of 1. So in order to keep the value the same, I'm going to add a decimal above and below and add a 0 so that I can keep dividing. 4 goes into 10 2 times. 2 times 4 is 8. When I subtract that, I have 2 left over. Bring down another 0, and 4 goes into 20 5 times. So my answer, 1/4, converts to 25/100ths as a decimal. Let's try 3/5. So I have another fraction here. Now another way that we can turn a fraction into a decimal is we can actually turn this into a percent, which means I have to have 100 in the denominator. So 5 goes into 100 20 times. 3 times 20 is 60. Now I can convert my percent into a decimal. And if you remember, percent to decimal means that I'm going to work backwards. I'm going to take my 60% and I'm going to move my decimal 2 places to the left. So 0.6 or 6/10 or 60/100ths, all of those are acceptable as equivalent decimals. So this time we're going to go opposite, and we're going to turn a decimal into a fraction. So there's a few things you can do, but the easiest thing to do is to put your digits, which in this case is 75, over the place value it is in. So this is 75 hundredths, so 75 goes over 100. If you can't remember your place values, you can look at how many places are after the decimal, and that's how many zeros go after the 1 in the denominator. Now we need to reduce this. 75 over 100 can both be reduced by 25. 75 divided by 25 is 3. 100 divided by 25 is 4. So this reduces to 3/4. And last we have 0.35. This one's a little bit more difficult because there isn't any money. In this case, 25 cents is a quarter, goes into 75 cents and a dollar, made that a little bit easier. This one we have 35 hundredths. So I'm going to put 35 over 100. Again, I have 2 places after the decimal. I have 2 zeros in the denominator, and now we're going to reduce. I know these are both divisible by 5 because they end in a 5 and a 0, so let's go ahead and start out by dividing by 5. 35 divided by 5 is 7. 100 divided by 5 is 20, and since 7 is a prime number, it does not go into 20. We are finished with our reducing. Now, there are many ways that you can convert in order to compare or order rational numbers, but in my opinion, it's easier to compare decimals than fractions. Now, if we look at our fractions down here, 3/4 and 7/20, in order to compare these, we have to have a common denominator, which means we're going to have to make some adjustments to the 3/4 in order to have a denominator of 20 that matches. So if you're comparing fractions, you have to have common denominators, which means there's an extra step that you have to do in order to make that comparison. If you're comparing decimals, it's just like comparing whole numbers, only you're looking at the places after the decimal. So it is easier to compare decimals than fractions. So it's probably going to be easier if you have a combination of fractions and decimals to convert everything to decimals. Let's move on here to step 3. For step 3, we're going to use the greater than or less than symbols when we're comparing numbers. So here's some examples. If we're comparing 2/5 to 45 hundredths, like we just talked about, let's go ahead and convert 2/5 to a decimal. We can have 100 in the denominator in order to easily move our decimal to change from a percent to a decimal, or we can put the top in the box and divide. So either way, we're going to have the same answer. So these are very common fractions: fifths, fourths, halves, thirds, sixths, and eighths. Those are ones that you probably are going to end up memorizing because you're going to see them a whole lot more often. So in this case, we know that 5 goes into 100 20 times, and 2 times 20 is 40. So that means that my decimal is 0.4 or 4/10. Now I can compare this decimal to this decimal. Now 4/10, they both have the same tens place, but this one, the 5 in the hundredths, is greater than the 0. So that means that 45 hundredths is greater than 2/5. For our second example, now we're comparing 6 and 8/10 to 6 and 3/4. So this is another very common one where fourths is in our denominator. So I can turn 3/4 very easily into a decimal. Now, the tricky part here is that when we change 3/4 to a decimal, 4 goes into 100 25 times. 3 times 25 is 75. So that means that 3/4 is 0.75, but you have to keep your whole number with the decimals. So now we're comparing 6 7/75 to 6 8/10. So if we look at our tenths, well, our ones position are both the same. So if we go to the tenths position, we have 8 and 7. 8 is larger, so 6 8/10 is larger than 6 3/4. For your fourth step, we want to pay attention to positives and negatives. So now we're not just comparing and ordering whole numbers or positive numbers. Now we have to make sure that we're putting our positives and negatives in the correct order. Remember, a positive is always greater than a negative. So let's do a practice problem. We want to order this set of rational numbers from least to greatest. And it's important to always pay attention to what order they want it in. There's a few things in math where they're very detailed on the order, and if you don't answer in the correct order, your answer is going to be wrong. So in this case, we're going to go least to greatest. Now we have a bunch of fractions and decimals here, so let's go ahead and make the conversions we need to. So we need to convert our fractions into decimals just to make the comparisons easier. Again, we have fifths in the denominator. 5 times 20 is 100. 4 times 20 is 80. And we need to move our decimal to make it a decimal here. And it's going to be a negative. So we have negative 0.8. Let's change this one. 1 and 5/6. 6 doesn't go into 100 evenly. So let's go ahead and use our other process here, and we're going to divide top divided by the bottom. Now 6 does not go into 5, so we're going to put a 0 and a decimal so that we can keep going. 6 goes into 50 8 times. 8 times 6 is 48. So when I subtract, I have 2 left over, and we're going to bring down a 0. 6 goes into 20 3 times. 3 times 6 is 18. When I subtract, I have 2 left over. I'm going to bring down my 0. And as we see here, whenever 6 goes into 20 3 times, that means I'm going to have 3 times 6 is 18. I'm going to continue to have 2 as a remainder, which means this 3 is going to repeat. So this is actually 1 and 83 hundredths with a repeating bar over the 3. This last one, 20 goes into 100 5 times. 7 times 5 is 35. Now let's move our decimal 2 places to the left. So this is a negative 35 hundredths. If you'll notice on this one before, the 1 and 5/6, when I converted to a decimal, I kept my 1 as my whole number here in front of the decimal. So now we need to order them from least to greatest. And it's important to remember whenever you're ordering a set of numbers that your answer is in the original form. So first, let's go ahead and order these. And we're going to start with our negatives because we're going least to greatest. So we want to actually determine which one is the biggest negative. And I can see I have a negative here, here, and here. So negative 0.8 or 8 tenths. I have a negative 1 and 25 hundredths, and I have a negative 35 hundredths. Now, when you're ordering negatives, remember it's opposite of ordering positives, where the bigger one is actually smaller. So here we have negative 1 and 25 hundredths is going to be our smallest number. I'm going to go ahead and mark that out. Then between the other two negatives, my negative 8 tenths is the next size. So I'm actually going to write it as my original fraction, negative 4/5. Next, I have negative 35 hundredths, which is actually negative 7/20. Now I'm going to finish with my positive numbers. My positives are 15 hundredths, 1 and 3 hundredths, 1 and 5/6. Well, I know that the one that is less than 1 is going to be smaller, so I have 15 hundredths. Now I have to decide between 1 and 3 hundredths and 1 and 83 hundredths. This one is definitely bigger because I have an 8 in the tenths place, and this one has a 0. So my next one is going to be 1 and 3 hundredths, and that means my last and my largest number here is 1 and 5/6. So I have 6 numbers in my answer, 6 numbers in my problem. I have my negatives listed first because we're going least to greatest, and I can double check and just make sure that the biggest negative is actually first. These are both less than 1. These are both in order here. So we're finished with our answer. All right, so now that we know how to compare and order rational numbers, let's go ahead and try a couple of practice problems. And for both of these practice problems, we're going to be putting our numbers in order from least to greatest. So let's go ahead with our first example. So we have 3/10, 1/2, 25 hundredths, 2/3, and 3/4. So we have to do some conversions here. We have to change some of these decimals and fractions into the same thing. Remember, it's easier to compare decimals, so we're going to convert our fractions to decimals. This first one's pretty simple. 1/2 is 5/10. And a lot of these, like I mentioned earlier, you'll eventually start memorizing and you won't have to really think about it or do the math. This next one is 2/3. Let's go ahead and divide this one so that we can figure it out. So 2 divided by 3. 3 goes into 2 0 times, so we're going to add a decimal and a 0. 3 goes into 20 6 times, which equals 18, and I have 2 left over. If I bring down another 0, 3 goes into 20 6 times, and if you'll notice, I'm going to have the same thing over and over, so that means that the 6 is just going to be repeating. So now we know that 2/3 is 0.6 or 6/10 repeating. This other 3/4 is pretty easy as well. Now, anytime you have 4 in the denominator, you're going to be able to use money to help you out here. And 4 of what goes into a dollar? Well, that would be a quarter, and a quarter is worth 25 cents. So if 4 quarters are in a dollar, the numerator is 3/4 worth. Well, 3/4 is equal to 75 cents, which is the same thing as 75 hundredths. So now we can go ahead and put our list in order from least to greatest. Remember, you always want to list the answers in original form. Now, because these are all less than 1, if you notice, everything has a 0 in the ones position, or the others are fractions without a whole number. So we're actually comparing our tenths position. And they all look to be different, so that's going to make this pretty simple. So of these tenths positions, the 2 is the smallest. So 25 hundredths is our smallest number. The next smallest number is 3, so 3/10. The next smallest is 5/10, so that's going to be 1/2. Our next smallest is 6/10 repeating, so that's 2/3. And our biggest one here in this list is 3/4. All right, so let's go ahead and try one more practice problem. Now, this problem, if you notice, actually has whole numbers. I have a 4, 5, 6, and a 4. This one, 15/4, does not have a whole number, but I know it's greater than 1 because the numerator 15 is bigger than my denominator. So let's go ahead and do some comparisons, because I don't have to turn 1/6 into a decimal and 3/8 into a decimal because I know that 4 is smaller than 6. So this is obviously a bigger number. But I do need to change 15/4 into a mixed number so that I can compare my whole numbers. So I'm going to go ahead and just turn that into a decimal, just to skip the step of turning it into a mixed number and still having to change that to a decimal. So let's go ahead real quick and divide 15 divided by 4. Well, 4 goes into 15 3 times, which equals 12. I have 3 left over. Since I have a remainder, I need to keep going, so I'm going to add a decimal and a 0 to bring down. 4 goes into 37 times. 7 times 4 is 28. I have 2 left over, bring down a 0, and 4 goes into 25 times. So I know that 15/4 is the same as 3 7/75. Now I can see my whole number is 3. So I can go ahead and now put these in order from least to greatest, and I only had to make one conversion. And that's because I can clearly see that these whole numbers are going to be put in order. Now, there's one other one I'm going to have to convert, and that is the 4 3/8. And the reason is because I also have a 4 3/10, and then a 4 3/8, and I'm going to have to compare those two. So let's go ahead real quick and change 3/8. I have two options. I can change 3/8 into a decimal, or I can turn 4 3/10 into a fraction and compare fractions. But in order to compare these fractions, they have to have a common denominator, which means that denominator is going to be really, really big. So let's go ahead and just turn our 4 3/8 into a decimal. So I'm going to divide 3 divided by 8. 8 does not go into 3, so I have a decimal, bring down a 0. 8 goes into 30 3 times, which equals 24. When I subtract, I have 6 left over. Now, these are still the same, 3/10. 8, bring down my 0. 8 goes into 67 times, which equals 56. And then 8 goes into 45 times. So now this equals 4 375 thousandths. All right, so now we can go ahead and put these in order from least to greatest. And really all we're doing is looking at our whole numbers first. 3 is clearly the smallest whole number, so that means that 15/4 is my smallest number on the list. Now I have to go to the next whole number, which is 4, and these 4s match. The 10th place matches. The 100th place, this would be a 0 because there's nothing there, does not, and 0 is less than 7. So 4 3/10 is smaller than 4 3/8. My last two, I have 5.5 and 6 1/6. Well, 5 is less than 6, so 5.5 and 6 1/6. So sometimes you're not going to have to convert all the fractions to decimals. You want to first look and see what we're comparing in order to find our answer. In this first example, they were all less than 1. So in that case, I had to convert my fractions all to decimals in order to make the comparison. In my second example, they all were greater than 1. So at first I'm going to compare my whole numbers, and since the whole numbers were not all the same, it made putting the list in order from least to greatest a little easier, and I didn't have to convert everything. Let's go ahead and talk about our steps one more time so we can recap here. First, when we're comparing and ordering rational numbers, we want to use a number line to order positive and negative rational numbers. Second, we're going to have to convert fractions to equivalent decimals or convert decimals to equivalent fractions so that we can put them in order. Remember, it's easier to compare decimals. Third, we're going to use a greater than or less than symbol when we're comparing two numbers. And last, we're going to pay attention to positives and negatives. A positive is always greater than a negative. So that's going to be true whether you're comparing them or putting them in order. The positive is always greater than a negative. Comparing and ordering rational numbers is going to take some time, especially since you have to do a lot of conversions. If you need more help after you watch this video, please be prepared to ask a couple of specific questions so that I can help you with your needs. But otherwise, you can watch it as many times as you need for help with this concept. Thank you for joining me today. This is Mrs. D signing off. I hope you have a great day. Bye.